Okay, my screen is visible, I guess. This was the program which we have seen yesterday, in which we are trying to perform, uh, we are trying to assign a integer pointer and an array pointer. Sorry, declare integer pointer and an array pointer and assign them to the same array. So in that, we were able to get these two addresses, and if you remember yesterday's program, so we are going to get these two addresses, and both will be same. If you remember that was 100 in both the cases. So once you get the term 100, and after that we are incrementing it by one. So being PTR, being P as an integer pointer, it is going to get incremented by one, or the block of uh, one integer, or or rather we can say it will be implemented by the size of block to which it is pointing. P is pointing to an integer, so block of 4 bytes, so it will be implemented by 4. Whereas PTR is pointing to the block of 5 integers together, that is an array, so size of 20, hence it will be implemented by 20. So that's what we have already seen. So this was outputting 100, 104, and this was outputting 120. So I hope that point was made clear. We'll go for the next program now. Uh, See this program, and if any one of you can answer this. Till this point, the program is absolutely same. So if I have an array of 5 elements, again I will write. Let us say that this is named as array. Let us say that the addresses are 100, 2, 10, and 6. Numbers are whatever may be the numbers. They are insignificant in our learning right now. So can any one of you tell me what will be the answers of these four? Uh, what it is going to print? Anyone can put their mic on and tell about this, or they can prompt in the chat box. What will be the answer for this? What this is going to print? No one? Not even a small try? Am I audible or not? You will try it. Can be wrong. Nothing wrong in that. The answer may be wrong.
Sir,
So
100.
100, and someone has put in the chat box also. Uh, Harshali also saying the same thing. Miss, at this point, do you say that it will be 100? Or okay, at what point, Miss? You are saying it at this point
Sir,
or
no, sir.
first print?
PTR equals
First print
upward.
up you are saying. Okay, these two will be 100. This is similar to the previous program. So I'm not bothered about that. I'm bothered much about this one. Size of these next four. These four lines. What will be the output for these four lines? What will be the output for this line? What it is going to print out? Printer. Harshali, good try, but I need answer for size of anyone else. What is the size of operator? Do you remember? 16. Okay, Shitish Kumar is saying that 16. Palash is saying as 8. Aditya Arikar 8. Can anyone of you explain? Aditya, can you explain this? Why it is 8? Aditya, your mic is not working. So can you post it? Shitish, can you?
Hello, sir.
Yes, Harshali.
Sir, I think the size of P is the size of address. Once, whatever the size of address of P is given, this will be the answer. I can't say particularly it's 100, 6, 8 or something like that. Is it right?
Yes. You're right. Kshitish, can I get the answer from you also? Kshitish, are you listening me? Kshitish Pantavne.
Hello, sir.
Yes.
Sir, P refers to the zeroth element of the array, and we are using percent %LD, so I wrote 16.
No, zeroth element and percent LD. Do they have any connection?
No, sir. Sorry.
Okay. Okay, Palash, size of P is equivalent to LD. Okay. Uh, Harshali, I am happy that you have thought over this. See here, when I say, when I write a few things. Okay, let us say that we have three variables: float pointer f, int pointer I, float pointer f, and character pointer. See, the lecture is more of listening than reading out. There will be lesser content on PPT, but you try to understand what I am trying to say. So there are three pointers I am defining: uh, pointer I, pointer f, and pointer c. This means the first means I is an integer pointer. That means I is holding the address of an integer value, or I will point to the location where an integer value is stored. F will point to the location where a float point value is stored. That means F is a pointer to a float variable. C is a pointer to a character variable. Means hold the address of a variable of type character. That means I, F, and C all are holding address. Let us say that I is 100, F is 200, and C is 300. So in this case, all are holding addresses, even though they are pointing to different type of variables, but the type of variable is different. The data which I, F, and C, all the three are storing are absolutely same. That means the address. Address will always be an unsigned whole integer value. It cannot be even 100.5 or 100.6. Okay, it will be a whole unsigned, means positive integer value. Okay, so always the value it is going to store will be an unsigned integer value. So whatever may be the size, whatever will be the size of an unsigned integer value for your computer, that will become the size of this. So answer, if I am saying answer is 8, this is also correct. If I am saying answer is 16, this is also correct. If I am saying answer is 4, this is also correct. On which these things will differ? See, if I am saying unsigned integer and I am using a basic compiler, At that time, integer size is 2. Integer size is 2 means the biggest value it can store, biggest unsigned value it can store is 65,000 something like that. Okay. But if address is crossing that, as nowadays the computers are having good memory capacity, uh, that moment 65,000 locations will be very small number. 65,000 will be very small number to address the number of locations which it is permitting. So we will not have uh, 2, but we will consider either 4 or 8, 8 or 16. So 16 is matching to LD, but this is just an access specifier. I'm bothered about this. So there is a possibility that the address which will be generated may be of a bigger size. Like I'll go for the previous slide. Here, see the output over here. See the address of P is given such a huge number, which cannot be accommodated using a unsigned integer or a percent d. That is why we are taking help of LD. If your computer size is lesser or memory is lesser, you can go for double only, or you can go for float for 4 bytes or double for 8 bytes. If it is bigger, then you are going for LD, which will be of 16 bytes. That is dependent on the computer which you are using. That is dependent on the system which you are using. But it will be, it is you going to return a number of maybe 4, maybe 6, sorry, maybe 4, maybe 8, or maybe 16, depending on your machine. What is the background of this? Even though the pointer variables point to a different type of variables, the data which it stores are nothing but the addresses. Okay, and addresses will be of same type of this. Okay, that is why size of a pointer variable will always be the size of the address which that machine is observing or that machine is practicing. Right? हाँ, इसमें क्या होगा? If I'm saying that integers are of 2 bytes, character are of 1 byte, and float are of 4 bytes, I is going to point to a block of 2 bytes, whereas F is going to point to a block of 4 bytes, and C is going to point to a block of 1 byte. But in all the cases, they are going to have same size of value they are holding. But that value will point to a different sized block, maybe an integer, float, or a yeah. So, if I am considering 8 in this case, this is also going to print 8 because pointer PTR and pointer P both are pointer variables, and ultimately they are going to hold only address. No matter what address they are holding. P is holding address to a single integer. PTR is holding address to the entire array. But they are holding address, and both size of both will be same. Size of both will be same. Okay. And what about this? This is a size of block to which it is pointing. The size of block to which it is pointing. So in this case, it is going to come 4 because this is pointing to an integer, and in this case, it is going to come out to be 20 because it is pointing to the whole array. Pointing to the whole array. Okay, so these are the two things which you need to keep in mind. So if I'm saying size of pointer P, that means it is returning the size of the block pointed by P. And if I am saying size of variable P, it is going to return the size of that variable. That variable is a special type of variable, pointer variable, hence it is going to return 8. Because we are assuming not in every PC you are going to get it 8, but you may get it 4, 8, 16, 32 as the capacity of computer uh, which is used for addressing. Okay? But in the size of P and size of PTR are going to be same. This is what my explanation about these two things, these two separate things. Is it clear? This prompt. Size of integer is 4. We are assuming that because most of the machines are having uh, a size of integer as 4. Okay? Most of the machines have that. That is why we are. Now, if you remember in yesterday's discussion, just a moment, I'll connect the charger. Fine. Coming back to the previous discussion, whatever we did, what will happen in this case, or rather, in this case also? I'm not sure. I just. So what's happening in this case? An array is defined. An array of 5 elements is defined, and I'm trying to access them using pointers. Okay. So here, what's happening? P is given a value. P is given a value, or P is assigned a pointer which will point to the first element of array. So whenever I say P plus 1, what will happen? This value will be incremented to the next element. So it is going to, so if this is P is pointing to A of 0, P plus 1 will point to A of 1. Okay. Similarly, if I am adding 2 into it, P plus 2, this is going to 8. Okay. Why I am telling you this is with the increment of a pointer variable, I can refer to the next element of the array. Okay, I can refer to the next element of the array. So A0, A1, A2 are the first, second, third elements of the array, where P is added with 0, 1, and 2. Similarly, I can go on adding, and I am referencing the next element of it, next element of that. So this one plays a very important role. It is not one; it is actually the one into size of the block to which P is pointing. That you remember. Okay, because we are moving to 2D array. That's what I'm repeating this. One is the size of the block to which P is pointing. In this case, if I am writing this, what will happen? It is incremented by 20 because PTR is pointing to a block of 20 memory places. That is 5 integers. That's why it will be incremented by 20. So it is also said as PTR plus 1. PTR plus 1. So here 1 is the size 20. In this case, 1 is the size 4 because P is an integer pointer, PTR is an array pointer. So that is the difference between these two. So 1, incrementing the pointer by 1 means incrementing it by the size of block to which it is referring. With this background, we are going for the next discussion of pointers to 2D array. pointers to 2D array. How we can declare a 2D array? We can declare a 2D array in this way, okay? And also I can declare integer pointer p, which can be assigned address of. This will hold the address of array. This way we can print, or otherwise I can directly mention pointer p here and D4. That means this it will be a pointer to a 2D array having 3 rows and 4 columns. Okay. Now we'll see how this addressing is done and how pointer works on that. Really a complicated discussion. Listen to it carefully. We'll repeat n number of times if it is not understood. Now this is the pictorial representation of array which you have declared by name array. Okay. There are 12 elements, 3 rows and 4 columns. 4 columns in each element, in each row. So this is the logical representation or conceptual representation of an array, which for our understanding we are using. For our understanding we are using. But actually memory look in the memory this will be the arrangement of this will be the arrangement of it. Means the first this now what can I say is this is 2D array means array of an array. So 2D array is an array of 1D array. 2D array is an array of 1D array. So there are 3 arrays it is having, row 1, row 2 and row 3. Row 1, row 2 and row 3. Or it is having column 1, column 2, column 3, column 4. So I can refer this as an array of 3 rows or array of 4 columns. Array of 3 rows and array of 3 columns. So either I can refer in this way, or I can refer in this way. Okay, so either I can say that it as an array of 3 rows, or I can say array of 4 columns. The terms used for these are, if I am considering a 2D array as an array of rows, it is called as row major representation. And if I am considering 2D array as an array of column, it is called as column major representation. Okay. So 2 words you can remember, row major and column major. Right now we are considering everything in row major. Means we are considering this as the array of I am considering this as array of rows, not as columns. So I am taking it as a row major. How it will be represented? This is just a conceptual representation of an array, logical representation of an array, but it is not possible for us to store this thing in this way in the memory. In the memory, you have to store it in contiguous memory locations. So what happens if 1D array is to be stored? What happens if 1D array is stored? First member, then second member, then third member, and then fourth member. This way it is stored. Here also it is stored in the similar fashion. What is the first member of this 2D array? Row 1. What is the second member? Row 2. What is the third member? Row 3. So in the same fashion, this is also stored. The row 1 is stored first. The first member is stored first, then the second, then the third. Okay. So in the sequential manner they are stored. So this is your first row. This is your second row. This is your third row. In other words, I'll say that this is the first member or 0th member of your 2D array. This is first member of 2D array, and this is the second member of 2D array. Okay, so that means these 3 members are contiguously located. So we are following the definition of array. These three members are continuously located or stored. Second thing is now each member of a 2D array is a 1D array in itself. Each member of 2D array is a 1D array in itself. That is why that has also to be stored in a continuous memory location. So this starts from A00, A01, A02, A03. So these are the four members which are stored. Once row 1 is finished, I am starting with the second row and then I am starting with the third. This is the first. This way we are storing. Now we'll have a splitted discussion, like we'll consider 2D array as a array of 1D array and how the pointers will work on this. Now let us say that. See what was happening in the previous case also. What I said, p plus 0 is going to access the 0th number, 0th element of the array. P plus 1 is going to access first element. P plus 2 is going to access second element. In this also it is happening the same thing. See here. Array is the name of, so it is array plus 0, ARR plus 0. It is going to access the first element. So what does this mean? I am not write ARR. I am finding it difficult to write because I am using mouse to write. So can I say that this element is A of 1, this element is A of 2? Is it possible? So ARR is equal to ARR plus 0. It is going to the, it is pointing to the first element of the 2D array. What is the first element of 2D array? This row, row 1, that is A0. ARR1 plus 1, it is going to point to this array that is A1. This is pointing to the second element that is A2. So each row is one element of the array. Each row is one element of the 2D array. That's why I can access them as A of 0, A of 1, A of 2. Here, see here. ARR points to the 0th element of an array. What is the 0th element? Row 1. So it is pointing to the 0th element of an array. Ultimately, it will be the 0th 1D array. What is the element of 2D array? Is a 1D array. So it's a 0th element of a. Let us say that its size is 5000. So it will be, this will be 5000, this will be 5004, 5008, 5012. So ultimately this next going to be 5060. So array plus 1 is point to the first element of an array. That is A of 1. So point to the first 1D array. Okay. First 1D array. Then the second 1D array. So I can generalize the statement as if I am saying ARR plus I, it is pointing to the ith element of the array. Ith element of the 2D array. That you remember. Ith element of the 2D array. That means the ith 1D array in the 2D array. In the 2D array. So this is the way the array members are referred using the 2D pointer, 2D array pointer. Is it clear? Shall we proceed? Shall we proceed further?
Hello, sir.
Sir,
Yes,
sir, last line.
last line. No? You are just, last line is just the generalization of these things. See here. This is array plus 0 actually. We are not mentioning it because 0. So 0th element is pointing to 0th element, first element is pointing to first element, second element is pointing to second element. So here also the same thing is there. So that's what we are doing. Ith element is pointing to ith element. Is this? We are generalizing the statement, these statements. Here right now we are considering just an array of 3 elements. That's why all 3 can be covered. There may be n number of elements at that time. Array plus I will point to the ith element of an array. What will be the element of 2D array? ith element will of 2D array will be another 1D array. So it will be pointing to the ith 1D array. In this case also, you can say 0th element of array means 0th 1D array. This is that array. Okay. First 1D array, this will be this array. Okay.
Yes, sir.
Anything
Excuse
else
me,
to be asked?
sir,
Yes,
you mean
Acharya?
to say that
Your
in
voice is
1 plus
cracking.
array plus 1, if we have to print 6, then we can write array plus 1 in a column bracket 1. Is it right?
I'll come to that. I'll come to that. I'll come to
Okay.
that. Right now, just make this thing clear. I'll come to every aspect of it. This point is clear, I hope. We'll proceed for 2D array. Just a moment. This pointer is a vast discussion. Okay, we'll have a good discussion in this. One by one, we'll come to know these things. Now, this point is clear. Now, what I am saying is, since array plus I point to the ith element of an array, on dereferencing it, means on normalizing it, it will get ith element of array, which is also a 1D array. That is true. Okay. So this itself is an array. This itself is an array, a 1D array. Right? Whole is a 1D array. Row 1 is a 1D array. Thus, what we can say that pointer I r plus 1, a plus 1 gives us the base address of ith idea. That's what right now Harshali was asking. How we can do it. I'll now come again. I'll write some addresses here as given. We are thinking that this will start with 5000. So this will be 5008. This will be 5000. 5004. This will be 5008. This will be 5012. Next next address will be starting from 5016, as we have printed it, and this will be started with 5030. So 5000 is the address of this element as well as is the base address of this 1D array. Okay. Basically, whatever 5000 I am writing here is the address of 0th 1D array, base address of 0th 1D array, right? So this is 5000 is the base address of this 1D array, 5016 is the base address of this 1D array, and 5032 is the base address of this array. Okay, that's what we are saying, that now if I am pointing to the address, particularly printing the address, what I can say is a plus 1, array plus 1 is going to return me the ith address of ith 1D array. Okay. We know that the pointer expression, this expression is equivalent to the subscript exception. So this is equivalent to, if I am saying this as a of 0, this will be ultimately pointer to a plus 0. Okay, this is a of 1, this will be pointer to a plus 1. This will be pointer to a plus 2. So I am dereferencing it as a of 2. Similarly, if I am saying pointer to a plus I, it is going to point to a plus a of I. So here it is written. So I can use this terminology here. Still, I am not addressing individual element, individual number. I am not addressing individual number. I am addressing the element of the 2D array. Element of 2D array is a 1D array. So it is this. This is equivalent to A of I. What is A of I? A of I is another 1D array. Another 1D array. So that is the ith member of a 2D array, which can be described with a subscript ARRI. So again, now I am relating these two statements, these three statements rather, saying that pointer ARR plus I, which is same as ARR plus I, will return the base address of 1D array. See here. A of 0, A of 0 is equivalent, A plus 0 is equivalent to A of 0. Am I right? What is A of 0? A of 0 is 1. No. A of 0 is 2. No. A of 0 is the whole array. Right? How an array is defined? Array is addressed. Array is referred. Array is referred with its base address. Okay. So this will be equal to 5. So pointer A plus 0 is going to return 5000. So also A of 0 is going to return 5000. Now here pointer A plus 1. A plus 1 means, now here see A plus 1. What will happen to A plus 1? It is, again, if a pointer is added by 1, I am going to add the memory locations equivalent to the size of the block to which that array is pointing. Array A is pointing to the block of 4 elements, that is 16 bytes. That's why if I am saying A plus 1, 1 is equivalent to 16, it will be incremented by 16. So ultimately with this simple calculation, this is going to be 5060. But what is that? It is also the address of A of 1. What is A of 1? A of 1 is the whole array. When I say A of 1, 0, it is the integer array. But if I am saying A of 1, it will be the whole array. Similarly for A of 2, this will be the whole array. So it is nothing but pointer A plus 2. This pointer A plus 1 referring to A of 1, first element of array. This is going to return 5000. So I am generalizing this statement. If A plus I is pointing to ith element of an array, I can say that pointer to A plus I gives the base address of 1D array. So that is equivalent to A of I. So A of I is equal to pointer to A plus I is equivalent to the base address of 1D array. That's why we are generalizing this statement in this way. Pointer to ARR plus 0 is ultimately A of 0. Okay, A of 0 means which is the base address of 0th 1D array. Also, it is base address of 0th element of 0th 1D array. Yes, this one. Address of this base. 5000 is the address of 5000 has 3 rows. It is the starting address of 2D array. It is the starting address of first element of the 2D array, and it is the address of first element, 0th element of 2D array. So 5000 is the address of 2D array. 5000 is the address of 0th element of 2D array, and 5000 is also the address of 0th element of the 0th element of an array. Okay, so 5000 has 3 roles to play. Similarly, ARR plus 1 is ARR1, which is base address of 1D array, first 1D array, which is the base address of 0th element, array of address of the 0th element of 1D array. So 5016, you can see 5016 is pointing to 5 and also pointing as a base address of this array. And thus we are generalizing the statement as this way. Right? We are generalizing the statement as this way. Is it okay? Any doubt to be asked till this point? Because we have a long way to go. Anything to be made clear? Nothing? I hope the things till now are made correct. Still, you work on this again and find out whether you have understood the things are correctly or not. We'll go in the next lecture. We'll go further in the same concept. Okay. So this is all from my side in today's lecture. If you have no doubts, you may leave the meeting. How could we access the elements of a 2D array? We'll come to that, Palash. The 2D array is not yet over, but it will be overdose if we are completing it today. है ना? तो अभी जितना पढ़ा है उस पे अभी फिर से एक बार आप अपने आप को रिवाइज कीजिए और कोशिश कीजिए कुछ समझ में नहीं आता है तो मुझे पूछिए and then we'll come to the each and every element how we can access the elements of 2D array in the next. So okay, if you don't have any doubts, you may leave. You can leave the class so that you can take a break and join for the next class. Thank you very much.